So good morning class, let us start. Today we will do some problems from Fourier series and then we will do some problems based on convolution. So I will give you a question, I will give you some time to solve it and then we can discuss the solution. So right now we are doing questions on Fourier series. So this is today's first question. I am drawing this periodic signal x of t. You can also draw it with me if you want. Minus 1 to 1 it is 2, then outside it is 0, then it starts repeating. Okay, so tell me what will be the time period of this signal looking at the waveform.
Three.
Yes, that's correct. So you have to determine magnitude of the Fourier series coefficient A2, that is when n or k that is equal to 2, you have to determine that. Is the question clear what you have to do?
Yes.
So you can start solving. I'll just write the formula for the calculation of Fourier series coefficient. So the formula is an is equal to 1 upon t, where t is the time period, 0 to t. Essentially you have to take one time interval. It could be 0 to t, minus t by 2 to t by 2, whatever. It has to be, the duration should be t for the integration. X of t e raised to the power of minus j n omega t. Omega is the fundamental frequency integrated with respect to dt. So take 3 minutes and then tell me the answer. Start solving.
Ma'am, at that t value we put the 3.
Yes, yes. T is the time period now. In this formula, T is time period only.
Okay. Ma'am, is it J n omega written?
Yes, yes. J and omega T. Minus J and omega T. So using this formula, first you will calculate An. Once you have the expression for An, you will put n equal to 2.
Ma'am, I got 1 by 3 omega bracket 1 minus e to the power.
Um, okay, just 1 minute is left, then I will start solving. You, if I'm not sure what you got, but you can try to simplify it further.
Okay.
You, when you get those e raised to the power of something, then remember that cos and sine. Cos theta is e raised to the power of j theta plus e raised to the power of minus j theta by 2, and similarly we have for sine. So using that you can try to simplify. Shall I start solving now?
Ma'am, just give me a minute.
Okay, actually the thing is we have to discuss convolution problems also, na? So okay. Ananya, shall I start?
Okay, ma'am.
Thank you. So we have this formula for an 1 upon mod t integration in interval t xt e raised to the power of minus j n omega t dt. If we look at this waveform, the time period will be 3 seconds because after this it will start repeating. So we know now that the time period is 3 seconds. Is this clear to everyone? Why time period is 3?
Yes, ma'am.
Bhosle, Diksha, Srinivas, is it clear? That time period is 3.
Yes, ma'am.
Alright. Now we have the time period which is 3. Let us go back to our formula. An is 1 upon 3. For integration, I choose this interval. So minus 1 to 1, it is 2. 1 to 2, here it is 0. So we will just substitute that in our integral. Minus 1 to 1, xt is 2. 1 to 2, it is 0. So I am not writing that integral. Now the leftover thing minus jn omega t dt. Let us integrate this. 2 comes outside of integral, it being a constant, and e is exponential. We get the same thing back, and this thing is divided. You know how to do the integration, right?
Yes.
So now I'll substitute 1 minus jn omega minus minus this negative and minus 1 will make it positive, divided by minus jn omega. An is, so I will take these terms outside. So 2 by 3 n omega j, minus sign I will absorb in the numerator. So j n omega minus j n omega. We have this. Now I want to convert this to sine. So what I will do, this you know na, that sine theta is equal to e raised to the power of j theta minus e raised to the power of minus j theta by 2j. So this is what I will use here. So for that I need 2j. J is there, so I will bring it here. J multiply by 2. So here also 2. So an is 4 upon 3 n omega sine of n omega. Now time period was 3. So omega will be 2 pi by t or 2 pi by 3. So an is 4 upon 3n, omega is 2 pi by 3. sine of 2 pi by 3 times n. 3 cancels. This becomes 2. So now I have an to be 2 by pi n sine of 2 pi by 3 into n. So how we got this expression of an, is this clear, class?
Yes, ma'am.
Alright, now we have an. In question we wanted to find magnitude of A2. So what we will do, we will put n equal to 2 here. So A of 2, 2 divided by pi times 2 sine of 2 pi by 3 times 2. So 1 upon pi sine of 4 pi by 3. We can write sine of 4 pi by 3 as pi plus pi by 3. So it will be minus sine of pi by 3, right? This is just trigonometry. This will be root 3 by 2.
Yes, ma'am. Ma'am, we will get minus 0.2756.
Yes. So we will just round it off. Now this is A2. So magnitude of A2 will be 0.276. Is this clear?
Yes, ma'am.
Alright. Next question. So in last lecture we discussed what does valid Fourier series mean. When I say valid Fourier series, I mean that my signal should be periodic. If my signal is not periodic, the Fourier series will not be valid. So this question is based on that only. Which of the following cannot be Fourier series expansion of a signal? You have 4 options. First one, xt is equal to 2 cos t plus 3 cos 3t. Second option, xt is equal to 2 cos pi t plus 7 cos t. Third option, xt is equal to cos of t plus 0.5. Last one, xt is 2 cos 1.5 pi t plus sine 3.5 pi t. So now take 2 minutes and tell me which one of these is not cannot be the Fourier series expansion of a signal. Start solving. Once you get the answer, now you can unmute and speak.
Ma'am, can we say just like this that D option would not be correct because there is a odd and even together?
No, no, no. We Fourier series we can have odd and even things. What we cannot have is aperiodic signals. So you have to check for aperiodic signals.
Okay.
You all have watched week 7 videos now.
Ma'am, for me, some videos are left because yesterday was OPP.
Okay. So this question which says which of the following cannot be a Fourier series expansion of a signal boils down to which of these signals is not periodic.
Ma'am, B.
Yes, that's correct. Others also got B, or are you still solving? Diksha, Bhosle, Srinivas, did you also get B, or are you still solving?
Still solving.
Okay, just one more minute, okay? Can I start solving now?
Yes, ma'am. Continue.
Okay, thank you. So let us look at this question. Like I said, the question that which cannot be Fourier series expansion boils down to which of these in which of these four options the signal is not periodic. So for periodicity, the ratio of time periods should be integer, or we can say the same for frequency also. So for option 1, I'm writing here only, okay? So for this, omega 1 is 1, omega 2 is 3. Ratio will be integer. Can you see that?
Yes, ma'am.
So for first option, the ratio is rational. Second option, pi, pi and 1. Is it rational?
No.
Yes, pi is not rational. So clearly this signal is aperiodic. So this will be my answer. Let us check others also. So here it is 1, 1, and like I said, DC term is periodic with any arbitrary period. So DC term does not affect periodicity. So by period I will call it frequency. Angular frequency will be 1. Let us come to this. So here it is 1.5 pi omega 1 omega 2 3.5 pi. Now pi cancels. What we are left with is again rational. So only B is the one which is not periodic. So it is the only one for which we cannot have Fourier series expansion. Is it clear?
Yes.
You guys remember now for periodicity the ratio of time periods should be integer. Sorry, rational. You remember now? Bhosle, Srinivas, Rohit, Diksha. Okay, next question. So you have this signal ZT, which is given by k equal to minus infinity to infinity ak e raised to the power of j k omega naught t. So it is given to you. This is a general Fourier series expansion, but it is given to you that ZT is real periodic signal, and You have been given that A3 third Fourier series coefficient is equal to 3 plus J5. You have to tell me what will be A of minus 3. So, hint for this question, you will have to use properties. Like if ZT is real, then what corresponding property do we have for AK? So, that is what you will have to use here. Do you remember if ZT is real, then what will the Fourier series coefficient be?
No, ma'am.
Alright, I will just write it then. If ZT is real, then AK will be conjugate symmetric. You remember what is conjugate symmetric?
Yes, ma'am.
Okay, so ZT is real means that AK is conjugate symmetric. So now you have to tell me A of minus 3, A of 3 is given. Take 2 minutes and then tell me the answer. Start.
So, ma'am, it would be 3 minus J5.
Yes, that's correct. Others also try to solve. Diksha, Bhosle, Rohit, Srinivas solve. You all remember na conjugate symmetry? If you don't remember, I have written it here. Diksha, are you solving? Same answer as Ananya? Okay. Bhosle and Rohit, Srinivas, what about you? This too you should be able to do now. Since we have to discuss other questions also, so now I will start solving. Okay, so in question, this is the Fourier series expansion if you realize. Now it is given that ZT is real periodic signal. If ZT is real, my property says that AK will be conjugate symmetric. Being conjugate symmetric, this property will hold true that AK is equal to A minus K star. So I can also write this as A of minus K is equal to AK star. Now AK, where K is equal to 3, AK at K equal to 3, that is A3, is given to be 3 plus J5. I want to find minus A of minus 3. So I will just simply conjugate this one. So it will be 3 minus J5 and that is my answer. Is it clear to those who could not solve? Is the solution clear? Bhosle, Srinivas, Rohit. Bhosle, is it clear? Okay. Srinivas, is it clear? Srinivas, is it clear or is there some confusion? Okay. Next question. So you have been given this signal xt. It has a period of 2 units and AK, the Fourier series coefficient, is given as half raised to the power of k when k is greater than equal to 0 and 0 when k is less than 0. Period is 2. These are the Fourier series coefficients. You have to tell me x of 0. So just for hint, I will write the general Fourier series formula and you have to use it here. So minus infinity to infinity ak e raised to the power of j k omega t. Take 3 minutes and then tell me the answer. Question is clear now?
Yes, ma'am.
Okay, start solving. So in this formula, if you substitute t equal to 0, you will get the expression of x0 and then you have to simplify it.
So, ma'am, will we get 1 by 2 and whole power k?
Yes, then you have to simplify it. GP na, it is GP.
Ma'am, that will be a constant, right? Because it is not depending on t.
It is not depending on t, but my summation is on k na. It is depending on k.
Okay, ma'am. Ma'am, is it 2?
Yes, it is 2. Someone else was also saying something. Ananya got the right answer. Others, someone was saying something, I guess. Alright, now I will start solving, so please pay attention. So, in the question, I have been given a signal xt which is periodic with period 2 ak. It's given that it is half raised to the power of k when k is greater than equal to 0. It is 0 when k is less than 0. In question, I want to find x of 0, that is x at t equal to 0. So this is the expression for general Fourier series. Now since I am concerned about x of 0, so I will simply put t equal to 0. So when I do that, I get this summation minus infinity to infinity ak e raised to the power of j k omega 0. So that becomes e raised to the power of 0 and e raised to the power of 0 is 1. So this is what I have left in my summation. Now let us substitute the value of ak. It is 0 for k less than 0. For k greater than equal to 0, it is half raised to the power of k. So x of 0 becomes 0 to infinity half raised to the power of k. So this is a geometric series and it goes up to infinity. The common ratio is half and it is less than 1. So I will use the formula, but just to show you, I will just write the series and so on. So using the formula a upon 1 minus r, 1 upon 1 minus half, that gives me 2. So x of 0 is equal to 2. This is my answer. Is the question, is this clear? The solution is clear?
Yes, ma'am.
Bhosle Rohit, is it clear? Okay, Rohit. All right. Next question. So this is based on unit step response. Remember when we were summarizing week 7, we talked about that unit step response, like if impulse response is given, I can integrate to get unit step response, and if unit step response is given, I can differentiate to find the impulse response. So this is based on this. Question number 5. Okay. Unit step response of LTI system is half minus half e raised to the power of minus 2t. You have to find the impulse response. So start solving, take 2 minutes. Question is clear now?
Yes.
Okay, start.
And will we get e to the power minus 2t?
Yes, that's correct. Diksha Rohit Bhosle, you also solve. Alright, now I will start solving. So in the question, unit step response of LTI system is given. I'm just repeating. Unit step response means when I applied unit step signal to the input, the output that I get is called unit step response. Similarly, impulse response means to the system I apply impulse signal and the output that I get is called as impulse response. And we know this relation that impulse response is derivative of step response, or step response is integral of impulse response. So here step response is given, so we will differentiate it to get the impulse response. D by dt half minus half e raised to the power of minus 2t. We will differentiate this. The first term differentiation is 0. Next, minus half minus 2 e raised to the power of minus 2t, that gives me a raised to the power of minus 2t. So that is my answer. Is it clear? Bhosle, Diksha, Rohit. Okay, now let us start convolution problems. So before we start, I would like to tell you 3 basic results that you can remember for the convolution. So these are now convolution questions. Okay, the first one is this ut is unit step signal, and t alpha means it is shifted by alpha. So when u of t plus alpha is convolved with u of t plus beta, you get r of t plus alpha plus beta. Rt is the ramp signal, unit ramp signal. So this alpha beta will add up, and this is what we will get. Is it clear what I wrote here?
Yes.
Okay, now next I have u of t plus alpha convolved with r of t plus beta. Then you will get t plus alpha plus beta whole square divided by 2 u of t plus alpha plus beta. So something like a parabolic signal. Next, x of t plus alpha. Xt is just any signal shifted by alpha convolved with delta of t plus beta. Sorry. Just a minute, please. Yeah. So the third one says xt is any general signal, delta t is the impulse one. This is shifted by alpha, this is shifted by beta, and this is the output that I get. So this alpha plus beta comes as it gets added, and xt stays xt, just shifted by alpha plus beta. So these three things are clear, like what I wrote.
Yes.
Okay, now the first question of convolution. Xt is equal to e raised to the power of minus t ut h of t is equal to e raised to the power of t u of minus t. You have to tell me yt, which is x of t convolved with h of t. Would you like to try to solve this?
Yes.
Okay. Take 3 minutes, then I will start solving. This is the convolution formula. I've just written it here for your reference.
Ma'am, is it e to the power minus tau r t minus tau?
Tau is the variable of integration, so you cannot have your answer in terms of tau.
Ma'am, I took tau as the other variable and t as this variable, which changes, which get
Uh,
integrated.
since xt and ht are in terms of this t, yt is also in terms of t. So the integration variable, it will be better if you keep tau and not t.
Okay, ma'am.
Can I start solving, please? Since other questions. Yes.
Yes, ma'am.
Okay, thank you. So xt h of t is given. This convolution integral is x of tau h of t minus tau d tau minus infinity to infinity. So x of tau will be e raised to the power of minus tau u of tau, and h of t minus tau will be e of t minus tau mu minus t minus tau. That gives me e raised to the power of t minus tau u of tau minus t. Let us substitute it back in our integral. Y of t is equal to minus infinity to infinity e raised to the power of minus tau u of tau e raised to the power of t minus tau u of tau minus t d tau. So let us take these exponential terms together. Minus infinity to infinity e raised to the power of t minus 2 tau u of tau minus t d tau. Now let us just sketch u of tau and u of t minus tau so that we could easily identify the limits of integration. So this is u of tau. Before 0 it is 0, and from 0 it is 1. So this is u of tau. Now let us draw u of tau minus t. So here now I will assume that t is greater than equal to 0. So if t is greater than equal to 0, tau minus t will be a delay. If it is a delay, will my signal move to left or to right?
Right.
Yes, so in delay it will move to right by t. This is 1. Now if we want to look at we are multiplying these two. So for t greater than equal to 0, when we multiply, before t we will be having 0 because this is 0. After t it will be 1. So my limit will become t to infinity for t greater than equal to 0. Is this clear?
Yes.
Others also it is clear now? Okay. So for t greater than equal to 0, we know our limit. Let us see for t less than 0. If t is less than 0, will my signal be advanced or will it be delayed? Tell me.
Delayed.
T is less than 0, u of t minus tau, will it be delayed or advanced?
Advanced, because it would be negative.
Yes. So negative negative will become positive, this negative and this. So positive means advance. So my signal will move to left by t. Now we have to multiply them. When we multiply, since in this time this is 0, so it will be 0, but then from 0 to infinity it will be 1. So that will be my limit for t less than 0. Is this clear?
Yes,
Okay,
ma'am.
now let us go to the yt. This, so yt, let us write for t greater than equal to 0. For t greater than equal to 0, the limit was t to infinity. So we will write that t to infinity, and this thing will stay as it is. This multiplication we have taken care of by deciding the limits. to the power of t minus 2 tau d tau. Now quickly integrate and tell me what will you get. Class, are you integrating this?
Yes.
Okay, I will also start doing. Then we can verify. Are you getting the same for t greater than equal to 0?
Yes, ma'am.
So what we did, we had this integral e raised to the power of t minus 2 tau d tau, limit t to infinity. So this is independent of tau, so this came out of the variable, came out of integration. We were left with this. We integrated, we substitute the limits, and finally we got this. Is this clear?
Yes, ma'am.
Okay, now let us do for t less than 0. For t less than 0, that is this one and this one, the limit was 0 to infinity. So let us put that 0 to infinity. This stays the same, d tau. Now if we integrate again, e raised to the power of t comes out minus 2 tau d tau 0 to infinity, just that the limits are different this time. Minus 2 tau divided by minus 2, 0 to infinity.
It would
e
be
raised,
1.
e raised to the power of minus infinity 0, e raised to the power of 0 1, so 1 upon 2 e raised to the power of t, right?
Yes, ma'am.
So now we have, this was for t less than 0. So we have calculated the expression for yt. For t greater than equal to half raised to the power of half into e raised to the power of minus t. And for t less than 0, half e raised to the power of t. Clear?
Yes, ma'am.
So this one problem was like based on solving the convolution. Now let us see how many we can do today. Next one. So here two systems are cascaded. The input to the first one is xt. This is h1t. This is h2t. This I'm calling the intermediate signal wt, y of t. Wt is given to be d by dt of x of t. H2t is given to be t times u of t minus u of t minus 5. You have to determine overall impulse response of the system. So, just to revise, when my systems are in cascade, then they will be convolved. So, if I call my overall response to be ht, it will be x1 of t convolved with h2 of t. Or I can also say yt is equal to ht convolved with x of t, which is this. So this is what cascading means. Now determine the overall impulse response of the system. And before you start, I will like to give you two hints. The first one, I'm writing down both of them. When input output equation is given to find impulse response, replace input with delta of t. Second, in linear operations, the order of operations can be changed. So these are the two hints. Now start solving. Is the question clear?
Ma'am, in y of t, you wrote convolved with x of t also. So what is x of t?
X of t is just any input. I wrote this equation just to tell you what happens to input and output in the cascading. That's it. You don't really have to use this. You have to consider this.
Okay.
So now the question is clear now.
Yes.
Okay, start.
Ma'am, here h1 of t would be delta t, right? Because sorry, differentiation.
What H1t will be what?
Differentiation, because omega t is getting differentiated by x of t, means there would be differentiation. That's why we got omega t as differentiation of xt.
So for finding h1 of t, you can use the first hint that when input output equation is given to find impulse response, replace input with delta of t. Okay, I will do one thing. I will solve this question. The second question is similar, so you can try to solve the second one. Is that fine?
Yes, ma'am.
Okay. So this is my question. Overall impulse response will be the convolution of h1 of t and h2 of t, that we know. Now, for the first, this h1 of t, I have been given this input output equation. Output is d by dt xt. So to find impulse response, that is h1 of t, I will replace xt by delta of t. W2 will then become h1 of t, right? So h1 of t will be d by dt of delta t. So I have h1 of t now. For h2 of t, it is already given in the question. So I just need to convolve these two. That's it. So ht is h1 of t convolved with h2 of t d by dt delta t convolved with h2 of t, which is t ut minus ut minus 5. Now
Ma'am, that T was
differentiation.
outside, right?
What?
T was outside, so U of T minus 5 will get multiplied by T also.
Yes. Oh, thank you. So this is what we have. Now let us, so now differentiation is a linear operation. So I can take, convolution is also linear, so I can take it, inside. Let me just write it and show it to you. So it will become d by dt, or maybe let us write it this way. D by dt delta t convolved with h2 of t, or d by dt. So differentiation I will do later. I will do convolution first. So if I convolve h2 of t with delta of t, what will I get? Let us go back to from where we started. Yes, this. So if I convolve any signal with delta of t, I will get it back and these delays will be added. So we will use the same thing here. So delta t convolved with h2 of t will become h2 of t only. So now my ht is just differentiation of h2 of t. So let us quickly differentiate it. D by dt, this is t ut minus t ut minus 5. This is what we have, and you know that tut is rt. You remember that now? RT ramp is TUT.
Yes, ma'am.
Yes. So now when we differentiate ramp, we will get unit step. For the second one, these two things are in product. So we'll apply the product rule. So I will differentiate which one first? Okay, I will differentiate ut minus 1, sorry, ut minus 5 first. So I will get t, and derivative of ut will be delta of t. So this. Now next I will differentiate t. So that will give me 1. I will have this. Now let us look at this term. When any function is multiplied with delta, what do we get? Like if you remember,
We will get
x of
T
x
naught.
of t delta t minus t naught, we will get x of t naught, right? You remember this property now of delta?
Yes, ma'am.
Now here t naught is 5, so this t will become 5. So ht will be ut minus 5 delta t minus 5 minus ut minus 5. So this is my overall response, overall impulse response of the system. Is this solution clear?
Yes, ma'am.
Okay, so next question is similar, and here you have a combination of cascading and summation. This was second, right? Okay, third one. I'll just write down the question. Consider the cascading of two systems as shown below. This signal over here, I'm calling WT. Plus from both the sides. So this one, this hole, I'm calling it as H2 of T. This inside this dotted box, I'm calling this as H2 of T. This is H1 of T. H1 of T is given to you. H1 of T is e raised to the power of minus TUT. So if you look at this question now, H1 of T and H2 of T are cascaded, and inside H2 of T, this differentiation of WT and WT, they are added. So the first question, there are three parts to this question. For the first part, you have to determine H2 of T. Find it out. H2 of T is the impulse response. So question is clear?
Yes, ma'am.
Okay, take 2 minutes and solve. I see that it's 11:08. Can we extend till 11:30?
Okay, ma'am.
Okay, thank you. Okay, start solving.
Ma'am, we have to just differentiate the H1 of T, right?
No, no, no. You have to find H2 of T. So H2 of T is impulse response. So for this second system which is dotted, if the input applied is impulse, what will be the output that I will get?
So that impulse response will get converted with H1 of T.
No, no, no. You have to tell me just H2 of T. So H1 of T does not come into picture here. See, what I am saying is, what is H2 of T? This is my system for H2 of T. For H2 of T, okay, for the second system, this input WT produces output YT. But when I want to find the H2 of T, which is the impulse response of the system, so when the input here is impulse, what will I get the output just from this? I'm not considering this right now because I want to find the impulse response of the second system. Oh, I'm sorry. What happened? I don't know how to remove it. Okay, sorry for that. So is my question not clear? What I'm trying to say, for this second system, you have to tell me the impulse response. For this second system, when this here becomes impulse, what will I get? That is what I'm concerned with right now. Is the question clear, or maybe I can solve it and show it to you?
Ma'am, and then it would be e to the power minus 0
No, no,
u
no, no,
0.
no. Ananya, H1 of T, you do not have to consider H1 of T. You have to determine impulse response of second system. So for second system, I do not care what this is. It does not matter. When I'm finding the impulse response, what I need to see is that here I am applying impulse. When I apply impulse, what will I get here? Is the question clear?
Okay, ma'am.
So now what I'm saying is, this is the system that I have. This is the system that I have. For this system, I want to find the impulse response. Is the question clear now?
Yes, ma'am.
What did Rohit say? Xt is equal to Wt for H2 of T. So now you can look at this figure, Rohit. This is what I have, and I want to find the impulse response for this system. So I do not care xt is wt or whatever. I don't care. I want h2 of t. For h2 of t, here I will be applying impulse. And when I apply impulse, the output will be h2 of t, and that is what I want to find out.
Ma'am, will that be d by dt of impulse response?
If you see here, there are two branches, this plus this. So you have to consider both of them for this
Yes, ma'am.
output.
So H2 of 2t would be d by dt of direct delta t plus direct delta t.
Yes, yes, now that's correct. So let us solve. So for H2 of T, I want the impulse response of the second one. Input I will apply as impulse. Output I will call it as H2 of T, and that is what I want to find out. Now there are two branches. So here it comes like this. So derivative of delta T plus the second branch, which just comes delta T as it is, they will be added, and I will get H2 of T. So H2 of T is, I'm writing this one first. So delta of T plus d by dt of delta of T. So this is the H2 of T that I wanted to find out. Here we use this. When input output equation is given, to find impulse response, replace input with delta of T. That is what we did. Now second part. You have to determine overall impulse response of the system. Overall impulse response, and I will call it as HT. So you have to determine HT. What will HT be? HT will be this convolved with this. So HT is H1 of T convolved with H2 of T. H2 of T you have find in the first part, you have found out in the first part. H1 of T is given. So now you have to solve. I will just copy paste it so that you can see. Okay, take 2 minutes and start solving. Question is clear now, second part?
Yes, ma'am.
Okay, start. Once you get
Ma'am,
that, tell me.
will we get e to the power minus t delta t?
Then you can simplify it further.
1.
No, 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 it will not be 1. Remember this property that we used? You have to use the same property, the one in blue. Oh, I'm sorry, मैंने property गलत लिख दी. Sorry, sorry. This will be the property. Sorry.
So we will get delta t.
Yes, yes, that's correct. So now I will start solving. H of t is h1 of t convolved with h2 of t. Now in h2 of t we have these direct deltas. So convolution with direct deltas gives me the same function back. So I will first use that, right? So h1 of t convolved with delta t plus d by dt delta t. So that will give me h1 of t convolved with delta t will give me what? Tell me.
H2 of t delta t plus
No, no, no. H1 of t convolved with delta of t. What will I?
H1 of t delta t plus H1 of t convolved with delta t plus H1 of t convolved with whatever is written there. D by dt delta t.
Now h1 of t convolved with delta t will give me h1 of t back, right?
Yes, ma'am.
This is what happens on convolution with delta, direct delta, and that is why we used it first. Now d by dt h1 of t convolved with delta of t will give me h1 of t. So this is what I have now. Now I will substitute h1 of t. So e raised to the power of minus t ut plus d by dt e raised to the power of minus t ut. Let us quickly simplify. Again, the product rule of differentiation will be applied. So I will first differentiate ut. So I will get delta of t. Next I will differentiate e raised to the power of minus t. So minus e raised to the power of minus t ut. So this and this will cancel because they're negative of each other. Now I'm left with e raised to the power of minus t delta t. Using the same property, I will get h of t to be e raised to the power of minus 0 delta of t, that is delta of t. So my overall response is delta of t. Is this clear? How we got this?
Yes, ma'am.
Diksha, is it clear? Rohit? Rohit, is it clear or do you have some confusion? Is it clear or you have? Oh, okay, thank you. All right, the last part is okay. Before we go to the last part, do you remember if we, when we talked about invertible systems, if we connect, if we have a system and we connect its inverse in cascade, then we get the same function back. So impulse response is delta t. So third part is kind of based on this. So now for the third part, you have to find overall output yt in terms of overall input x of t. So going back to my system, now I will take this whole system. So for this system, input is xt, output is yt. You have the impulse response now. So you have to tell me the relation between input and output of this system. The question is clear?
Yes.
Okay, so tell me the output. Do you want me to keep this figure in image or this third part here in image? In on the screen, sorry. You want me to keep this visible on the screen or this?
This one.
Okay.
Now we have to find the inverse of this, right?
You have to find the output yt in terms of the input xt. And this is an LTI system. I will just give you 2 minutes, not more than that. You have to find overall input yt in terms of overall input xt.
Okay, ma'am. Ma'am, it will be d by dt e to the power minus t ut convolved with xt plus e to the power minus t ut convolved with xt.
Okay, I will solve it. I'll show you. So when we have an LTI system, then can we say for an LTI system, the output yt is equal to the input given xt convolution impulse response of the system. Is this true?
Yes, ma'am.
Now, I just found out in this part that ht, the overall impulse response, is delta t. So I will just substitute it here. So xt convolved with delta of t. What will I get?
Xt.
Yes, I will get xt. So my overall input xt in terms of overall, sorry, overall output yt in terms of overall input xt is yt is equal to xt. So yt is equal to xt. The impulse response was delta t and I get this. So this is actually an invertible system, the one we solved. Is this clear, the third part?
Ma'am, when we will say invertible system, when x of for t would be equals to y of t.
Actually, what here we had now, we had h1 of t, we had h1 of t, and the second system was h2 of t. So, in invertibility, we studied if I have one system, I cascade it with its inverse, then I will get the I will get the same out input at the output, or the overall impulse response will be delta of t. So this is what I get. So h1t is an invertible system, h2t it is its inverse, or we can also say h2t is an invertible system and h1t is its inverse.
Okay, ma'am. Ma'am, one more doubt. In
Yes.
when we found that h of t, then we considered x of t as delta t, right? So
Not
when
when we found out that h of t is delta of t, this one.
yes, ma'am. Then we considered x of t as delta t, right?
Yes.
So, ma'am, now we are not considering xt as delta t. So the whole thing would change here also.
What in the third part I did was this relationship is true for any LTI system now, that output is the input convolved with its impulse response.
Ma'am, that I get it. But when we are not taking x of t as delta t, then that h of t would change also, right?
Yes, when input to any system is delta t, then the corresponding output we get is the impulse response. But if my input is not delta t, then it will not be called impulse response. We will get an output, but it will be some other output. If instead of delta t I apply ut, then the output I will get will be called as unit step response. But if I have any input xt, then the output I get will simply be yt. But for output to be impulse response, input has to be applied as impulse response to the system.
Okay, ma'am, got it.
Clear now?
Yes, ma'am.
Okay, so now the next question. It's 11:27. Actually, I had some more questions. So, okay, we will just take this to be the last question then. And so this is based on that convolution property which I told you about, two rectangular signals of same width and different width. Do you remember?
Yes, ma'am.
So this is based on that only, and some scaling also. So this is my first signal, x of t. What happened? Minus 2 to 2, it is 10. Now the next, sorry again. Sorry for that. So this is xt. This is h of t. Minus 4 to 4, it is 8. Zt is equal to x of t by 2 convolved with h of t by 2. So this is your question. You have to first find the waveform for z of t. Then there is a following question that I will ask once you tell me. So the question is clear now, na?
Yes, ma'am.
Okay, start solving. Okay, before you start, tell me what is the width of xt
4,
and of ht.
8.
Now, Diksha, you tell me, when widths are different, do we get a triangular signal or do we get a trapezium? Ananya, you tell me, do we get a triangular signal or a trapezium?
Trapezium.
Yes, we get a trapezium. So now you know we will get a trapezium. You have to solve, but before you solve, you need to see that this is x of t by 2, h of t by 2. t by 2 will xt, will this be expanded or will it be compressed? X of t.
Expanded.
And h of t will also be expanded. So you will draw these two signals, find their width, and then tell me what trapezium will you will get. So how much time do you need for this?
1 minute.
I mean, you have to tell me the complete trapezium, like the starting and mid end point, and the ones where the slope changes and amplitude and slope, all of that. 1 minute will be fine for that.
Yes, ma'am. Ma'am, can you once wrote that formula in A and B terms because I kind of forgot it.
Okay, I will try to copy paste it from that session then. Did I tell that in the end?
Yes, ma'am.
Wait, which session is this? Session 1 only. Where did it go?
Ma'am, it was in the last.
It's not here. I don't know where did it go. It's not here.
Ma'am, I'll check it in the PDF you sent.
That is what I was checking. Was it in week 5?
No, ma'am. It was in week 7. Week
Just
7 first session.
yeah, it was in week 5. So this is for equal weight. You want me to copy paste it for unequal weight now?
Yes, ma'am.
Okay. You need to see both the screens now. Is this fine? This much?
Yes, ma'am.
Okay, start. 2 minutes should be fine.
Okay.
This is the last question for today, and there's just another part which will hardly take 1 minute.
Ma'am, the starting would be minus 12 and end would be 12. And those point where the slope 0 starts, it would be minus 4 to 4.
Mm.
Slope would be 80 and the constant part would be 160.
No, it will not be 160. Rest of the things are correct. Just check the constant part again.
Okay, ma'am.
Rohit, do you remember this? Rohit, do you remember this? Okay. Diksha? Okay, you
Ma'am,
guys are. Yes.
it will be 640.
Yes. Ananya got the correct answer. So Ananya, you can try and do the second part also. For second part now, you have to tell me number of discontinuities in ZT.
Okay, ma'am. It will be 2, right?
No, it will not be two. What exactly is a discontinuity? When there's a sharp change, like in ut from at t equal to 0, or in these rectangular pulses, like for xt at minus 2 to ht minus 4 4. So that sharp change is where we have a discontinuity.
So ma'am, we have to tell it for x of t and h of t,
No,
or
no,
both
no.
and all.
You have to tell me for zt.
But ma'am, in a way, there's no sharp change, right?
Yes.
So it would be 0.
Yes, that's right. And also, if you go back to the maths that we studied in school, so when we talk about discontinuity, then when the left hand limit has to be equal to the right hand limit, and also it should be equal to the value of the function at that point for it to be continuous. And if you see that thing is being satisfied here, even at the extremes, that is why it is continuous.
Okay, ma'am.
Rohit, you got the answer? रोहित आंसर आया? ये प्रॉपर्टी ही तो यूज करनी है. चलो आई विल सॉल्व. So we have xt and we have h of t. But for convolution, I need x of t by 2 and h of t by 2. So t by 2 means expansion. So what will I do? I will just multiply by 2 here, 2 here, 2 here, 2 here. And that will give me h of t by 2 and x of t by 2. This is, I think, from week 1. I will just copy paste them and change it here only. So my limits will change. In x of t, it was minus 2 to 2. X of t by 2, 2 will get multiplied, minus 4 to 4. H of t, it was minus 4 to 4. For h of t by 2, it will be multiplied by 2. So minus 4 into 2, 8. 4 into 2, 8. And yes, this is t by 2, t by 2. Zt is the convolution of these. So when we use the property, we will have the following. This is z of t. So according to the first property, the first point of the shortcut, for lower limit, it is the sum of lower limit of both signals. So lower limit of this plus lower limit of this, minus 8 minus 4, 12. For upper limit, I will take the sum of the upper limits of both. So 4 plus 8, it is going to give me 12. For this value and this value, what I said was, take one lower limit and one upper limit, and then the remaining you will take as it is. So minus 4 plus 8 will give me 4. So that has to be the greater value, so that will come here. Now the remaining one, this and this, you will take. So that gives me 4 minus 8 gives me minus 4. So minus 4 comes here. Now let us find the slope. So for slope, what is the trick? Multiplication of both amplitudes. So I will multiply 10 and 8. What will I get? 80. 80, the positive slope, and this will be the negative slope. So minus 80. Now for the this constant amplitude, you have to take multiplication of fourth point, multiplication of both amplitudes into smaller width. So what is this width? 8. What is this width? 16. Which is the smaller width? First one, 8. So I will take 8. So multiplication of both amplitudes, that is 10 into 8 into the smaller width, which is again 8. So I get 640. So this is my ZT. Is it clear now, Rohit? All right. So now the next part was you have to determine number of discontinuities in ZT. So Rohit, tell me how many discontinuities are there in ZT? Rohit, 4 discontinuities. Okay, where at which all points? Okay, I'll do it since we're already out of time. So I think according to Rohit, he was mentioning about these 4 points. So discontinuity happens in a place wherever there's a sharp change. Do we have any sharp change here? No, we don't have, because the slope is changing gradually. So sharp change is not there. And if we go back to maths for the definition of discontinuity, or rather continuity, then left hand limit should be equal to right hand limit, and it should be equal to the value of function at that point. So here let us see this point. We can see that left hand limit and right hand limit both will converge to the same value, and it will also be equal to the value of the function. Now here same thing, same. So everywhere the left hand limit is equal to the right hand limit, which is equal to the value of function. So there is no point, there's no place where Z is continuous. So the number of discontinuities in Z is 0. Is it clear now why Rohit, the discontinuities are 0? Okay, so since we are already out of time, so I don't think we will be able to do more questions. Or do you want to practice more? It's all up to you.
Okay, okay with anything.
What?
Okay with anything.
You tell me what you want.
Okay, more questions.
All right. 3 are left. Rohit, that is fine with you? Anyways, let's just start. So, for fifth question, h of t is given to be e raised to the power of t ut plus e raised to the power of bt u of minus t. The question is LTI system will be stable if you have been given 4 options: a greater than 0, b greater than 0, a less than 0, b greater than 0, a less than 0, b less than 0, option D. So there are these 4 options. You have to tell me which of them is true. And just to refresh your memory, when we know that there is an LTI system and the impulse response is given, so if impulse response is absolutely integrable, then my system will be stable. So to make this absolute integrability thing calculation easier for most of the times, what you can do, ht should be 0 when t tends to both plus and minus infinity. So whenever my time either tends to plus infinity and minus infinity, for both of them, if ht is 0, then my system is absolutely integrable, and hence my system is stable. So this is the thing that you will be using here. So using this, tell me which of the options is correct. Is the question clear?
Yes, ma'am.
Okay, do it.
Ma'am, A would be less than 0 and B would be less than 0 also. But this will become 0 for t tending to infinity, not minus infinity.
You want to take more time or should I solve?
You can solve.
What?
Ma'am, you can solve. I
Okay.
think it should be A less than 0 and B less than 0.
A less than 0 is correct, but B should be greater than 0. Let us see why. So let us take the first term, e raised to the power of at ut. So t goes from 0 to infinity. So we know that at minus infinity, anyways, it is going to be 0, right? Because of ut, presence of ut, right?
Yes, ma'am.
Now, when t tends to infinity, then for this thing to be 0, ut is 1, so we don't really bother about that. But let us see e raised to the power of at. If t tends to infinity, and if I want this to be 0, then a has to be negative, because if a is negative, then negative into infinity will make it minus infinity, and then e raised to the power of minus infinity will give me 0. So that is why a will be less than 0. If this has to go to infinity, a should be less than 0. This is
But
how you did now.
yes, ma'am. But one doubt.
Yes.
When A would be negative,
Huh.
then t tending to minus infinity would be infinity, right?
No, no,
Because
no. It will not be, because this is e raised to the power of at ut. Ut is the unit step signal. So ut is 1 from 0 to infinity, and before that, that is for negative time, it is 0, right?
okay, ma'am, got it. Let me do that second one also.
Okay.
Ma'am, B would be positive because in that it will that t would be minus infinity to 0, and if we take B as negative, then it would go to infinity, because minus B minus infinity will make it infinity.
Yes, that's correct. So the second term is e raised to the power of bt u of minus t. U of minus t. So u of minus t is 1 from 0 to minus infinity. And after 0, that is from 0 to infinity, it is 0. So we know for sure that t equal to infinity, so it is going to be 0. Now at t equal to infinity, just what Ananya said, it will be 0 if b is greater than 0. Because b greater than 0, negative time, it will make minus infinity. E raised to the power of minus infinity will be 0. But if b is less than 0, then e raised to the power of something negative into minus infinity, it will give me e raised to the power of infinity, and it will go to infinity. This is not what I want. So b greater than 0 satisfies this, and this satisfies this. So the correct option will be option B. A less than 0, b greater than 0. Can we move to the next question?
Yes.
So for the next question, it is based on direct delta and convolution. So you will have to use some properties of direct delta in this. Delta of t plus 1 by 2 convolved with delta of minus t plus 2 gives me a times delta of t minus b. You have to tell me the values of a and b. The question is clear?
Yes.
How much time do you need to solve this?
1 minute.
Okay, once you get the answer, tell me. Rohit, you understood the previous question now? Rohit, did you understand the previous question, or do you want me to repeat it?
Ma'am, is it minus 2 delta t plus
Just tell me the value of A and B.
minus 2 a value?
No, no, no. I think you did not use the properties correctly. So I will start solving now. So before I start the property, okay, A is there in the question. Maybe n. A of n times t is 1 upon mod n delta of t. Do you remember this property?
Yes, ma'am.
This
I
is what. Okay, so let us start. So delta half, I took half outside, t plus 1. So this will be using the above property 2 times delta of t plus 1. This is clear. This is fine, Ananya, the first one.
yes, ma'am.
Now second one, delta of minus t plus 2. So I will take minus 1 common here. So I get this. Now using this property again, it will be delta of t minus 2. Is this clear?
Ma'am, that minus 1 would be outside, right?
This property, it is modulus now.
Oh, okay, ma'am. So it would be 2 a is equals to.
Yes. Now we will be convolving these two. 2 times delta of t plus 1 convolved with delta of t minus 2. So 2 times delta of t minus 1. Delta convolved with delta will come as delta. These time shifts will be added and the amplitude after multiplication will be 2. Is this clear?
Yes, ma'am.
So that means A is 2 and B is 1, because in the question there was minus. Minus was already there, right?
Yes, ma'am.
Okay, now I guess it's the last question. Yes, last question based on differentiation. So xt is given to be t times ut minus ut minus a, where a is some constant. You have to find yt, which is d by dt of xt. So question is clear, Ananya?
Yes, ma'am.
Rohit, is the question clear to you? You can start solving. Rohit, you can also try to solve this question. So here you can try to form ramp for both of them. Then you know that the derivative of ramp is unit step.
Yes.
And you can also try to sketch yt if possible. Ananya, once you get the answer, now tell me.
Ma'am, I'm getting u of t minus ut minus a plus r of t minus rt minus a. And I don't know how to find e.
How to find?
A.
A is a constant, it is given in the question. So answer will be in terms of A only.
Oh, okay, ma'am.
Okay, can I solve now?
Yes, ma'am.
Okay, so I would actually first try to form ramp for both of these terms to simplify the derivative, because then if I have ramp, I can simply say that the derivative will be unit step or step. So I will multiply tut minus t u of t minus a. Right? This is what I have. Now what I will do is I will add and subtract the following term. So I will subtract minus a times u of t minus a plus a times u of t minus a. This is what I added, okay?
Okay, ma'am.
Just added, subtracted these two. Now I will take these two terms together. So t ut minus t minus a u of t minus a times u of t minus a. Now TUTs are of t ram, right?
Yes, ma'am.
Second term, t minus a u of t minus a. So it is a shifted ramp r of t minus a, and this term comes as it is. Now I have these, I will differentiate. And I know that the derivative of ramp is unit step. Yt is d by dt x of t. So the derivative of the ramp first will become ut. The second will become minus u of t minus a. And this will become minus derivative of unit step is direct delta. So I get this. So this is my yt. Now I will sketch it. Ananya, will you tell me what will be the plot for these ones that I've highlighted with green?
First, it will be 1 from the 0 starting. Then it would be negative 1, and that point would be A.
Yeah, so when I sketch ut minus u of t minus a, so ut to starts from 1. Then we have this term. So it starts from a and it is minus 1. So beyond a, all of this will be 0 because they will get cancelled, right?
Ma'am, there would be one negative spike type of amplitude A, right?
Yes, this one we will have because of this term.
Yes, ma'am.
And this was because of the first two terms.
Yes, ma'am.
So clear now?
Yes, ma'am.
Yeah, so that's it from my side. So I have discussed some of the convolution problems, and now week 7 is done. On Wednesday, you will be having week 8.
Okay, ma'am.
Okay. Thank you for joining. Have a great day.
Ma'am, you too.
Thank you.
Bye. Bye.